it's frozen. Just give me a second. All right, so altitude of a right triangle. So we're now moving into the land of similar right triangles. So not just regular old similar triangles, we're talking about similar right triangles. Still talking about triangles within triangles. All right. So there's a very special case when it comes to similarity when we draw an altitude from the right angle vertex of a right triangle to its opposite side, which is the hypotenuse. Does anyone know what an altitude actually is? The height of the triangle. Does anyone know a special feature about the altitude? It creates a right angle. So it intersects the side perpendicularly. So the altitude partitions or divides the hypotenuse in a very specific way due to similarity. So here's how it works. If you have the right triangle ABC, where angle ABC is the right angle, which they already marked for us right here, they drew an altitude from B to the hypotenuse. So AC has been drawn. And the angle BAD 55 is marked. Now, here's the question. How many right triangles are in this diagram total?
Actually, no, one, because only we only know that's like look at three. Look at
Okay, show of fingers. How many think there are? If you have 3, you're correct. So, remember, linear pair. So, linear pair, that means this angle is also 90. So, we have the big whole triangle. We have the smallest right triangle right here. And we have the slightly bigger one over here. So, there are 3 right triangles total. So, here's 1. Here's 2. And then the entire picture itself is 3. Now, once it's defined all the measures of the acute angles, all right? So, which of those 3 triangles do you think it'd be the easiest to find the angles to? I would start with the yellow one, or ABD, all right? Because we had the 55 and the 90, so that means the third angle has to be what? 35. Where else can I go? So CBD, all right, this one, what's the relationship to the 35? They're complementary, meaning they add to what? 90. So that'll be 55. So this angle has to be what? 35. So if you notice, they all have the exact same angle measure. So what do you think all 3 triangles are to each other? They're similar. By angle, because they have all congruent angles. So why can we say that all right angles triangles are similar? Because of angle. Or angle, however you want to state it. So triangle ABC is similar to triangle ADB, which is similar to triangle BDC. So all 3 of those triangles are similar to each other. And just for reference, blue triangle, yellow triangle, green triangle. Now, we're going to redraw these triangles, but to be in the same orientation as the big one. So we're going to redraw the two small triangles to be the same orientation as the larger one. All right. So first off, I'm going to draw my big one in its proper orientation. So A, B, C. So this is 55, 90, 35. All right. So if I draw the green triangle, so the medium triangle, so it's slightly smaller, has to be the same orientation. So I have a 90, 55 here, and a 35 here. All right. So what vertice would go with the 55 for the green triangle? Green triangle. What vertice goes with the green 55? B. What goes with the 90? D. What goes with the 35? C. All right, and then the last one, since I don't want to do it in yellow, I'll do it in orange. Close enough. All right, so that's the smallest one. So right angle, 55, 35. So what letter goes with the 55 for the yellow? A. 90, D, and 35, B. Now, the similarity statement, it's just this one. I jumped the gun. All right. So that similarity statement that we wrote up top is going to be the same thing there. You don't have to rewrite it. Just draw an arrow to it because I jumped the gun. So, again, when I created these similarity statements, I already in my head went through and matched up the angles. All right, that's kind of how you can figure out how to name the triangles correctly. Because remember, you got to name triangles based off of their corresponding parts. So the first letter should be the 55-degree angle. So whatever letter is connected to the 55-degree angle for all three triangles. So A, B for the green, A for the yellow. Then I did the 90-degree angle. So that's B, B, and D. And then the 35, so that's C, C, and D. All right. So that's how you name them. Any questions on how you write those statements? All right. Now, here is how we do the altitude hypotenuse theorem. So, in general, anytime an altitude is drawn from the right angle vertex of the hypotenuse, it makes three similar right triangles. So, it's the original triangle before we drew the altitude, and the two baby triangles that get formed by the altitude. All right. Where the if you notice, all right, altitude is right here. And if you notice, the non-hypotenuse, so the legs of the original blue triangle, before we do the hypotenuse, becomes the hypotenuse for the two baby triangles. All right. So the original legs then become the hypotenuse of the new baby triangles, which kind of leads us into what we're going to be doing next. So, in the diagram below, we have triangle EFG, so that's our original, with an altitude of GH, drawn to the hypotenuse EF, and it is known that EH is 2, HF is 8. So I'm going to go ahead and mark what we know. EH is 2, HF is 8, and that's all we know. Now, I'm going to go ahead, like I said yesterday, colors is very helpful. So I'm just going to color in my three different triangles just so I know where they are. And then I'm also going to draw my other 90-degree angle at the altitude, just so I know where that is as well, because that's always a good reference. 90 degree, you should always know where that 90 degree is at all times. Okay, so first things first, we're going to mark all of the congruent angles. So the 90s are already marked. All right. So let's start with our big triangles. So what other angles within the other triangles would be congruent to angle EFG? So G, nope. HGE. That's the other one. Because if you notice, that one's going to have to be a different size because we don't know if those two angles are congruent or not. Which also corresponds to the other angle of the big blue triangle. So guys, it doesn't really matter how you mark it. If you started just with one of the little triangles and worked your way around, that's fine. All right, so let's say I start with green triangle. I mark this triangle. I mark this angle. All right, that means that the other angle has to be different. So I'm going to mark it with 2 ticks. Now, since they're complementary, and these two angles are going to be complementary, because it's a right triangle, that means if they want to add the 180, they have to add the 90, because we already have a 90-degree angle. All right, that means that these two angles are going to be congruent. All right, which makes that since these two angles have to also be complementary, these two angles are congruent. Just pick an angle, work your way around. Does that make sense? How I did that? All right. All right, so now we're going to draw the 2 smaller right triangles below the larger one, but in the same orientation. I am just going to draw all of them over again, okay? Just so there's no confusion. So I'm going to draw the blue one first, so the big one. So this is E, G, F. I want to make sure I mark everything correctly. Now, question. If 2 and 8 are right here, what's actually the length of the side EF? 10. So I'm going to put a 10 there. Now, I'm then going to draw the green triangle, which is the medium one, so slightly smaller. So my 90-degree angle is at H. I should have the 2 here, 1 here. Which letter goes with the 2 ticks for the green? G. What goes with the 1? F. Now, here's the question. Where's the 8 go? Because the 8's the only thing attached to the green triangle. Where's it go? HF. So right there. And then finally, the smallest triangle. So right angle. That right angle's still at H. 2's here. 1's here. So for the yellow triangle, what goes with the 2 tick? What letter? E. For the 1 tick, what letter? G. Now the 2 is what's connected to the yellow triangle. Where would it go? EH. It goes on the side. Now, why the heck are we doing this? Because this will help us figure out what the other sides are. All right. And we can use what we know about similarity to determine that. Okay? Because the next question asks us, use similarity of the 2 smaller triangles to determine the length of GH. All right. So, let me ask you this. If we look at the original before I separate them all, what's true about GH between the 2 little triangles? It's the altitude. Now, what's also going to be true about it for both triangles? So GH here and GH here. What's going to be true about it? They're going to be what?
Reflexive.
They're reflexive, which means that they are congruent. So GH for both triangles is going to be congruent because they originally share that side. All right. So these two GHs are going to be congruent to each other between the two little triangles because they are the same side. Right? If you look, that's the side that those two triangles share. So we're going to call both of these X. Now we're going to set up a proportion to solve for X. So let's do corresponding side with corresponding side. So let's start with the green triangle. Which number do you want to start with first, X or 8? Okay, let's just start with X. So that's the side GH. What corresponds to X on the orange triangle? 2. Because they're oriented the same way, they're corresponding. We're going to set equal to, yes.
Can you explain how you got the 2 and the 8 again?
They told us that. They just flat out told it to us up here. Yeah. All right. So now, since it has to be same triangles across as well, we're going back to the greens. We're going to put 8. And what corresponds to the 8 on the orange? The X. So these two correspond. Now, I'm going to do what I've been doing for the past couple of days and cross multiply. So what's X times X? X squared. X plus X is 2X. X times X is X squared. Because remember, anything times itself is going to be its square. All right. What's 8 times 2? 16. Then how do I solve for X? Square root both sides. So what's X equal? 4. All right. So both of these are 4. Now, we then want to use the smaller right triangle. So we're going to use the orange to find the length of GE. Now, here's my question. If we're finding GE on the smaller orange triangle, so let's call that Y. Which of the other two triangles, the blue or the green, shares GE? The blue. All right. So that means that these two sides have to be congruent. So these are the two triangles I'm going to use when I set up my proportion. So someone set up one of the proportions for me using corresponding sides. 10 over Y. All right. So if you go with the 10 up here, its corresponding side is the other hypotenuse here. So since we use the blue triangle first, that means we have to use the blue triangle for the other side first. So I'm going to put Y over what? 2. So these two are corresponding sides. And we're going to solve pretty much the exact same way. So we're going to cross multiply. Y times Y is Y squared. The 2 is from the original problem. They gave it to us already. So the 2 that we originally started with, it still remains. So you know the 2 up here that we originally got? It's still there. All right. What's 10 times 2? 20. Yes.
Can you not just use Pythagorean theorem? Like plug in.
You could, but we're just showing the proportions for right now. Because you do have to be able to do these proportions. But you could use Pythagorean theorem because we do.
Anytime or just get lucky.
No, Pythagorean theorem is a theorem for a reason.
So I don't have to do this.
If you have enough sides. All right. But the problem is that you don't necessarily will have enough sides every time. All right. So take the square root of both sides. Y is equal to the square root of 20. Now, they want in the simplest radical form. So how do I simplify radicals? You do.
Oh, you said take out the.
So we're going to break down 20 into factors of 20 where 1 is a perfect square. No, we ain't approximating.
10.
So what are 2 factors of 20 where 1 is a perfect square? Where 1 is a perfect square. 4 and 5. 4 is the perfect square, 5 is not. So I'm going to rewrite this as y is equal to the square root of 4 times 5, which we can then rewrite as y is equal to the square root of 4 times the square root of 5 separately. Well, we know what the square root of 4 is, right? 2. So y is equal to 2 square root 5. You guys will have to do this in your quadratic units, so might as well practice now.
So will any of the answers be on the test be like that? Be y equals to your series?
How is like I'm really confused.
Okay, so guys, when it comes to simplifying radicals, all you do is take whatever's under the radical, break it down into 2 factors where one of them is a square root. All right, and then you can rewrite it as that perfect square times the other number. Then there is a radical rule that says, just like with fractions, like when we talked about yesterday, like if you're adding 2 fractions over the same denominator, you can break them apart. If you're square rooting 2 numbers being multiplied together, you can break them apart to be the square root of 4 times the square root of 5. And then square root of 4 we know it's 2, and so it's just 2 times square root of 5.
We're gonna have to answer it in this way. Will it say it's the simplest radical?
Yes. If it says approximate, you put in your calculator. If it says simplified radical form or exact, you do this. Because this is exact.
Will there be an open-ended question asking us to do this?
I don't know. I don't remember what's on the test.
And like if 2 and x are corresponding for like G and H and G and H, and G and H and G and H are those squares are the same or like equal, then
Well, they're corresponding. Doesn't mean they're going to be equal. Corresponding does not necessarily equate to equal. They're just proportional. So if we actually took proportions of all 3 of these sides, so this would be 2 square root 5. And this is 2 square root 5. If we took proportions of, say, all of the vertical sides, like if we did 4 over 2, and they would all pretty much be the same thing. All right. Any other questions?
So with the side, the missing side lengths, y equal, or would it be 2 times the square root of 5 of both of them?
Yes, for both of them. It's for both. Because they share it. So if we go back up here to our original where it's combined, doesn't GE appear on both the blue and the yellow?
is there any way to do this like while keeping this roll instead of like breaking it down?
You could, but it can get confusing really quick. So, I mean, it's totally possible. You totally could, but you'd have to be really careful. All right. So, like, you have to really pay attention to what's what. All right. Let's try another one. So, it's so like what Charlie was saying, like, can we do it with just the one triangle? You can, but you got to make sure that even though they're oriented differently, you got to be really careful about which sides correspond with which. All right. So we now have the original right triangle RST, where the altitude RU is drawn to the hypotenuse ST. So this is my original triangle. I'm just going to outline it. And it makes 2 triangles. So a baby one and a toddler one. So we're going to mark all of the congruent angles first. So to make things easy, I usually just mark the angles of the big triangle. So we have the 90-degree angle here. So this will be some angle measure. This will be the other one. And then, of course, the altitude right here is 90. That makes it easier to mark the other two. So all I did was mark the blue triangle. All right. Now I can mark these other two angles because I already have another angle I can play with. So how many ticks should the other yellow angle have? 2. How many ticks should the other green angle have? 1. Now, we're going to redraw the two orientations of these triangles. All right. I'm going to leave the blue one alone, but you need to recognize that the blue is, we're looking at like the colored one. We're talking about the bigger one. But I'll draw the smaller two. So I got my green, right angle, 1, 2 ticks. So R goes with the 1 tick, U goes with the 90, S goes with the 2 tick. Then my yellow one, which is slightly smaller, 90, 1 tick, 2 tick. T goes with the 1 tick, U is with the 90, R is with the 2 tick.
How do you determine like what is where?
Because I'm looking at tick marks. All right, so I know that originally, if I want to be oriented the same as the blue, I'm looking at how the blue's oriented. So the blue has 1 tick, the 90, and the 2 tick. So that's how the other two should be oriented. 1, 90, 2. And then I just match based off of the letters that's with them. All right, so if RU is 10 and TU is 5, we're going to find the length of SU. So I'm going to mark everywhere that I have RU on all 3 triangles. So RU, so that's 10, 10, 10. TU is 5, so 5 and 5. And they want us to find US. So here and here. Now, based off of our 3 triangles, which 2 would be the most helpful to find what X is? The yellow and the green. All right, because you look here, the stuff that we need for the blue, some of it's inside the triangle. Like this would be like X plus 5 if we add them. It's too much. All right, we don't have enough outward sides that give us it. But these, we have plenty of outside or exterior sides that we can use. So now I can set my proportion. So I'm going to start with my, oh Lord, my yellow triangle. That's the ones where I have everything. So let's start with RU for the yellow or the orange, however you want to put it. What's the corresponding side with that 10 on the yellow? X. So these two are corresponding. I'm going to set it equal to, all right, X. Actually, no, that's a lie. 5 over, all right, what's the corresponding side on the other one? 10. All right, so these two are corresponding. So then you cross multiply and solve. So 5x is equal to 100. So x is equal to what? 20. So that means that this is 20 and this is 20.
The one that's equal to 20.
It would be anywhere it says US. Anywhere it says US, because that's what we were solving, or SU, whatever. Same thing. Nope. Just anywhere, because we were solving for SU, so anywhere it says SU on any of the triangles, that's what X is. Yes.
It's just when we break down the triangles and rotate it to look like the
Yes. You want to orient them the same way. Because once you orient them the same way, remember what I said, the hardest part is figuring out the corresponding sides. The easiest way to figure them out, though, is to orient them the same way. All right, because if they're oriented the same way, you can physically see which side goes to which. Because remember, corresponding just means same spot. All right, now, sometimes you'll be asked to solve problems involving these types of triangles without being given an image to work with. So you have to carefully draw the diagram. So, in triangle MNP, where P is the right angle. All right, so I'm going to draw that triangle first. So before I even go on, I'm going to draw the big right triangle. Has a right angle. And we know that P is the right angle. So that means if I go around N and M. Now, you could have flip-flopped M and N. It doesn't matter. All right, as long as you made P the right angle. So pay attention to which one they say the right angle is. They then drew an altitude PL to the hypotenuse MN. So MN should also be your hypotenuse, which it is. So I'm going to draw an altitude from P all the way to some point here. We'll call that L. And it's an altitude, so it hits in 90-degree angles. Then ML is 9, LN is 3, and they want us to find the length of PN. So ML is 9, LN is 3, and they want me to find the length of PN, so it's over here. I'll call that X. I know it's on top of some words, my bad. Now, every time you do this, my recommendation, go through and mark all the congruent angles. All right? So if I start with just the big triangle, let's make this one 1 tick, this one 2 ticks. So for this triangle, what would this angle be? 1 tick or 2 tick? 2 ticks. For this one, how many? 1. Now, keep in mind, this is not drawn to scale. All right? So, just for my sanity, I'm going to draw my other 2 triangles so I can clearly see them. So I have right angle, 2 tick, 1 tick. I don't know which one of them is smaller because, again, I did not draw to scale. So 1 angle, 2 tick, small tick. I'm just going to label them based off of where my angles are. So I'm going to start with this bottom triangle. Really? So the right angle's at L. For the bottom triangle, the 2 tick will be at P, and the 1 tick is at N. Right angle's still at L for the second triangle, so the top one now. 2 tick is at M, 1 tick is at P.
Can you please say that again, like a little slower?
So all I'm doing is just matching. All right. So I did the bottom triangle first. It doesn't really matter. I knew the right angle was at L. Then 2 tick was at P. 1 tick was N. That's how I labeled it. So I wanted to orient the same way as the big purple triangle. So it was 90, 2 tick, 1 tick. All right.
So like, if you're labeling, you can just like take each triangle that's like already connected and just label them like
Exactly.
that's what I was confused about. I thought that you were just like trying to find stuff like the angles that would work and then put them together.
No, I'm literally like, since I already marked, that's why I told you to mark them first. Because from there it's just matching. All right. So I'm then going to mark all the designated sides on either triangle. So I have ML is 9, so that's on the pink triangle. LN is 3, that's on the green. And PN is X. Now, keep in mind that technically this side is equal to what? 12. So we can add the 9 and the 3. So which of the two triangles would be most beneficial to use? The green and the purple. All right, because I have enough information. So how do you know which triangles to use? You need two sides for each, where at least one of them is going to be the variable. All right, so you have to have two sides given. Even if one of them is the variable, it doesn't matter, but two sides have to be marked. Because technically the purple one has two sides marked, the green has two sides marked. The pink only has one. So the pink wouldn't be that useful to us because we don't have enough information. All right. So how would I set up my proportion? So 12 over x, because 12 and the x are the same, or they're corresponding, I should say. And it's equal to x over 3, because Pn and Ln are corresponding. Square root it, it'll be x squared is equal to 36. What's the square root of 36? 6. It'll be. Why would I use 3 instead of 9? Because I'm using the green triangle and the purple. 9's not even on this triangle. But on this triangle, for the corresponding side, we had to add the 9 with 3 to get 12. So it's also a game of which triangle can I use? Which triangle do I have enough information? So again, the only way you can tell that is you're looking for two triangles that have at least two sides filled in. All right. So if you notice, these two are filled in, these two are filled in. You only got one on this one. It's not enough info.
Wait, so how did we again get the P into X? Like how did we know it was X between them? Just because we didn't know the other side was zero?
Say that one more time.
So that X between P and
Well, it's because they want us to find PN. Okay, so here.
You're basically separating.
All right. Everyone look at me. I have here a right triangle. How do I know? I took a piece of paper, which we all know that paper have 90-degree angles. All right, and I just cut across their diagonal. All right. Now, I'm going to cut from this right angle to the other two all the way down. So I'm going to leave one of them uncut. That's going to be our original. All right. So I just made the altitude. Okay. So I now have two baby right triangles that I made out of this. So watch this. So if we look here, here's my original. All right, let's say I oriented it like this one. All right. This one would be the one that goes up top. This one,
Sorry, I oriented that wrong.
this one would be the one that goes up top. So it's literally just kind of a matching game. You know the right angle's got to be down here. So this is how they would overlay. All right. See how they overlay?
Yeah.
Okay. So then, if I wanted to take them apart and orient them the same way, so I take the orange triangle and I orient it to look like the yellow. So I just gotta flip it over. Boom. If I take the pink triangle, I want to orient it like the yellow. So the right angle's here, so I flip it over. Boom. That's what we're doing. We're literally breaking apart the two triangles and just orienting them so they look the same. Does that make a little bit more sense?
Yeah.
All right. Any other questions on that? All right. So let's do this last problem. So in the diagram below, GH is drawn as the altitude from point G to the hypotenuse EF. You know what? We ain't doing this one. Screw that one.
Didn't you just flip it over HG and then?
Yeah, but it wants us to do like transformations and stuff with like tracing paper. I ain't doing that. You don't have to worry about that. Okay, so your homework for tonight is pages. What page did we just end on? Okay. So we're doing 14 and not 14. We're doing 15 and 16, and you're going to exclude number 1. So don't do number 1. So that's your homework for tonight. You guys can go ahead and get to it. You got a solid 30-ish minutes. 15 and 16. And you're excluding number 1. Shelf. Yep.